Now we're going to take a look at what we are familiar with as exponential growth. And there's a model or a function that describes exponential growth. And this is the general model for the equation of the function. F of x equals some constant c times another constant a raised to the power of x. When you have the variable as your exponent, that is an exponential function. If you have the variable as the base of your exponent, so, just in comparison, if you have something like x squared, x is the base, and the power is a constant, in this case 2, so that would be quadratic. But in this case, we have the reverse. We have our exponent in the, or our variable in the exponent, and the base, which is 2, is constant and fixed. And we require that a be greater than 0. You can't have negative constants because then you would have an alternating effect. If the exponent is positive, you'd have a negative, and if it's negative, you would have a fraction, etc. So it's just kind of, we keep a greater than 0 to keep things simple. So here I plotted some points, and these are 3 basic points that give me the shape of, I think I added 1 extra in there. If my exponent is a 2 and I take, minus 2, I'm going to get 1/4. Because I'm squaring the 2, but the negative means that I take the reciprocal, so it's going to become, instead of 4/1, it's going to become 1/4. And same here, when you take 2 to the negative 1 power, you take the reciprocal of 2/1, which is 1/2. So here's the basic shape of an exponential function. All exponential functions pass through this point 0, 1, because any base like 2 raised to the power of 0 is going to equal 1. Anything raised to the power of 0 is 1. So 0, 1 is always a point on a basic exponential graph, no matter what your base is. And then when you plug in 1 as your exponent, you're just going to have your base raised to the power of 1, which gives you your base. So this point is going to be 1, 2. 2 because that's our base. So whatever your base is, you're going to have 1 and then your base as a point on the graph. So when you put in negative values, you're going to be taking reciprocals, and so it's going to get closer and closer to 0 because you have fractions that are getting smaller and smaller as you put larger negative numbers in. And if you put in positive exponents, it's going to increase very rapidly, as you can see from this graph. So here's some examples. I've already graphed f of x equals 2 to the x. And we are asked here to evaluate f of 1/2. So f of 1/2 is going to be 2 to the power of 1/2. Remember, the variable is the exponent. So the 1/2 goes into the exponent. And what does an exponent of 1/2 mean? That just means that you're taking the square root, because it's a rational exponent. So that just means the square root of 2. Here, g of 1, I'm going to plug in 1, and I get e to the 1 power. E is a constant that is used in exponential functions in nature. And it's approximately equal to 2.7. And if you're curious about where e comes from, you can go to YouTube and find lots of videos that will show you where e comes from. So it's approximately equal to 2.7. And then here we have an exponential function. I'm plugging in a 2 for x, and it's 7 to the minus x. So that's going to give me 7 to the minus 2. And that minus just means I'm taking the reciprocal. 7 squared is 49, so I'm going to take the reciprocal of 49. All right, so let's stop there and we'll look at some graphs of these functions. Let me share my screen. Let's see here. Here you can see the graph of f of x equals 2 to the x. And let's do another one. Let's say f of x equals 3 to the power of x. F of x equals 4 to the power of x. So you can kind of get a feel of how they all have the basic shape of kind of like, looks to me like a boomerang, that sort of rapidly increasing function. And you can see they all pass through the point 0, 1. And again, anything to the power of 0 is 1. So if you plug in 0 for x, you're going to get 1 for all different exponential functions. Now let's look at what happens when you take the opposite sign. So if I take 2 to the power of now negative x. Wait, that's not what I want. All it does is take the red graph and reflect it across the y-axis. And that's because I replaced x with negative x, and that's the inside of the function. These are exponential functions, so the exponent is the inside of the function, and I put that negative in there so it reflects across the y-axis to give me this curve here. All right, I hope this introductory video gives you a feel for how exponential functions work. I'm going to go ahead and look at some models of these exponential functions or applications in the next video.